There's a countdown.
Yeah. I'm just going to check with the team and make sure the video is streaming before I have you go through introductions again. All right. So sorry for the awkward silence, folks. Thank you for joining us tonight. We had a little trouble getting started, but we're happy to be here tonight. Thank you for joining us and your patience, of course. My name is Mandy. I run the 4-H STEM Challenge program here at 4-H. This year, our STEM Challenge is Mars Base Camp. It takes you through a journey of landing on Mars, building a rover, exploring the surface of Mars, growing food on Mars to sustain human life, and sending a message back home with your discoveries. Today, we have Brian Day and Emily Law from NASA to discuss the Tour of Mars video you may have seen earlier. If you haven't seen it yet, don't worry. You can check it out later. It's really awesome. But they're here tonight to answer any questions you might have about what it's like to work for NASA, what you've learned about Mars so far from our past missions, and the Mars Trek system that is used to make the video. So before we get started, I'd love to have Brian and Emily introduce themselves and tell us a little bit about what it is that they do at NASA. So Brian, if you want to start.
Thank you very much, Mandy. Hi, I'm Brian Day, and I work at NASA Solar System Exploration Research Virtual Institute, where we study the solar system and how we're about to explore it. We look at planets, moons, asteroids, with an emphasis on our moon, near-Earth asteroids, and the moons of Mars. I especially enjoy studying rocks from outer space, meteorites, things like, oh, this thing right here. And I occasionally get to go on what we call Mars analog studies, where we go to some of the harshest environments anywhere on the Earth, places that have things in common with the environment on Mars. So we are able to figure out how we're going to live and work on Mars and how life might adapt to that kind of an environment. A few years back, I got to fly on a mission where we actually got to observe pieces of a comet Keys, burning up and entering the Earth's atmosphere in a meteor shower. But by far, the coolest thing I get to do in my job is work with Emily and the wonderful team at JPL that develops the solar system treks. Those are something that you're going to become very familiar with, especially our Mars Trek portal. So thank you very much.
Awesome. Thank you, Brian. I have a lot of questions already just for your introduction, but I'd love to give Emily a chance to tell us what she does at NASA. Emily?
Thanks, Mandy. Hi, everybody. It's an honor to be a part of this live Q&A session. I'm a project manager and also a computer scientist at the NASA Jet Propulsion Laboratory, JPL, where I started over 20 years ago. JPL does a lot of robotic missions that we send out to the solar system to study all the planets and all the asteroids of different planetary bodies. Currently, I support 3 program offices overseeing a variety of data science, data-intensive system and technology projects for Earth science, planetary exploration, and also JPL Enterprise data and analytics programs. So leading the development and operation of the solar system tracks is actually one of my favorite duties, not only because track portals are really cool and fun for people to use, to learn of all ages. The project also gives me great pleasure to share space explorations with people like you, and it also provides me the opportunity to work with colleagues like Brian's and also collaborators like Mandy. Thank you.
Awesome. Thank you, Brian and Emily. I know you're super busy people, so thank you for joining us. We'll get right to it because I see a lot of great questions coming through. I'll leave mine until the end in case we run out, but I'm pretty sure we won't. So first off, I think a great question for our 4-H audience that I've seen a couple of times now is, will there be jobs for agriculturists and farmers?
Absolutely. Especially when we start thinking about living and working on Mars, you have to realize Mars is a long way away. It's a good 6-month journey when everything lines up just right. So that means you just can't go back to the Earth to go to the grocery store for supplies. We're going to need to learn how to live off the land when we go to Mars. And so that means you're going to end up having to grow some crops. And so your studies in agriculture could be very, very relevant to living and working on Mars.
That's actually a really great plug for the Crop Curiosity game in Mars Base Camp, where you learn all of the different things that you need to grow food on Mars, because Mars has a very different surface and atmosphere than Earth, which actually is a good segue into a question we have. How did Mars become so dry? I know that in the Mars Trek video that you created, Brian, it talks a little bit about the surface features of Mars, and that, you know, we do see evidence of water on Mars, but at one time we think it was much warmer and wetter, right? So what happened?
That's true. And it's a really interesting question. We're trying to find out just what did happen, but we know that at one point there was liquid water flowing across the surface of Mars, but it is a complete desert today. So we have some ideas of what may have happened. The Earth has a magnetic field, a global magnetic field around it that acts like a force shield, and that protects our Earth's atmosphere from the solar wind, this high velocity wind coming out of the sun. And so the solar wind gets diverted around the Earth by our magnetic field. Mars used to have a global magnetic field too, but apparently long ago that magnetic field shut down. And so what that means is the solar wind is now free to blow directly against Mars's atmosphere and kind of blow that atmosphere away. And so over time, Mars's atmosphere has gotten thinner and thinner and thinner. Now that atmosphere acts as a blanket. It helps keeps things warm. But as that blanket got thinner, the temperature got colder. And so while there's still water to be found on Mars today, it's not in the liquid form. It's almost all in the form of ice.
And sort of following up on that question, so we're not really sure why all of that happened yet, right?
No, we're not. Again, we have ideas. Mars is a smaller world than the Earth. It's about half the diameter of the Earth. Because of that, it has less insulation. Its layers of rock are thinner. So it probably didn't do as good a job of holding in its internal heat as the Earth did. Our magnetic field here on the Earth is generated by this convecting liquid fluid iron core. And it's acting like that because it's very hot. But if Mars lost some of that internal heat and some of that convecting in its iron core slowed down, then that perhaps is what shut down the magnetic field on Mars. That's an idea, but we still don't know for sure. We have a lot of exploring to do on Mars.
Another great question coming in. Have we ever found any signs of human or alien type of life on Mars?
That's a great question. As of today, I don't believe we have found any aliens and those kind of figures on Mars. However, we did have find water on Mars, and that leads to us to believe that there was actually life on Mars long ago when there was water. So before the loss of Mars magnetic field that might have caused the solar wind to strip off the planets of its atmosphere, making it not possible to hold the liquid water and making it really extremely cold and dry, there potentially before that there was water and there was actually life on Mars. But we don't, have any evidence of any other creatures or aliens on Mars today that we have found.
But there is one really interesting hint, possibly. So observatories here on Earth and our rovers on the ground on Mars occasionally get whiffs of methane gas in the atmosphere. And that seems to be a seasonal thing. The amount of methane in Mars's atmosphere changes by the season. Now, here on Earth, methane is typically produced by life, by perhaps bacteria. Now, it's too early to say if that's what's happening on Mars. There could be other ways that methane could be generated. It could be geological processes, something we call serpentization, or all kinds of other new things going on. But one of the primary causes we find here on Earth is biology. And so it is possible, just possible, that we may have already gotten the first sniffs of life on Mars.
So that brings up a really good topic that you did cover in the Mars Trek video about all the awesome missions that we've already flown to Mars, the instruments that we've sent, the things that we've learned so far. Kind of a basic question that we've gotten, which is great to cover, I think, because it's important to know how we actually study another planet that's so far away, is how do we even get to Mars? How have we gotten all of these rovers and all of these landers to Mars?
Do you want to do that, Emily, or you want me to take that?
How? Because with today's advanced technology, we were able to build very powerful, rockets, the spacecraft, the robotic missions that the spacecraft that we built would be able to, using those rockets and be able to take us from Earth to Mars, even though it takes 6 months since from launch of spacecraft to get it into Mars orbit or have the rover actually drop off on the Mars. It's because of all this advanced technology that we have today that we were able to do it. And also our visions that we want to go there, our commitment to explore beyond the Earth, to search for life and understanding, Mars surface and the planet's evolution. That's going to help us prepare for the future human exploration over there. That's how we can do that.
Yeah. Very, very good points. And don't make the mistake. Going to Mars is really hard. And if you look at the history of missions to Mars, you'll see a whole lot of missions that failed, that either missed Mars altogether or hit Mars in an unfortunate way. So it is really challenging to get to Mars. And as Emily notes, we've gotten the technology refined now to the point where we're doing a lot better at it. But one of the key things that enables us to do this is when you have a spacecraft that is so far away, you've got to have good communication with that spacecraft. If you're driving a rover or you're orbiting around Mars and you want to get all this wonderful information, you need to have good communication. And so fortunately, that's something that NASA and especially at JPL, they have set up something very, very specifically targeting that. And that's something that Emily used to work on, and she can tell you about it in a little more detail.
So what Brian's talking about is the NASA's Deep Space Network, short for DSN, which is an international array of very huge antennas that support interplanetary spacecraft and some Earth satellites as well. So DSN is used to track and also control the spacecraft and bring back valuable data and observation that really help us improve our understanding of the solar system and beyond. So the DSN consists of 3 facilities strategically placed at Goldstone, California in the US, in Madrid, Spain, and also in Canberra, Australia, in order to constantly track the spacecraft. The facilities are called Deep Space Communication Complex, and each includes a gigantic 70 meters antenna that is wider than a football field. So the bottom line is that when it comes to making long-distance call, it's really hard to top NASA's Deep Space Network, and that is really crucial for space exploration.
We had one question come in, speaking of communication, that, potentially once humans are on the moon or on Mars, they will have to communicate back to Earth. When do you think, so this is a little bit of looking into the future, but when do you think that we'd be able to send humans to Mars?
Well, NASA, has, first of all, NASA right now is focusing on returning humans to the moon, which will serve as a stepping stone for us to go to Mars. There was talk about, potentially sending humans to Mars in the 2030s, maybe 2035, along that timeline. So, but it's not firm yet. Brian?
That's a very good point. We have Mars as a very key destination ahead of us. And that's part of why we're sending these rovers there, is to answer some of the key questions. But as Emily points out, going to the moon is an important step in going to Mars. We have to learn how to live and work in deep space. We've had people living in space for a long time on the International Space Station. That's a very different environment than the moon or Mars. That's still inside that protective force field of the Earth. Once you get beyond low Earth orbit, out to the moon and Mars, you have a very harsh radiation environment. You have a lot of things to really have to deal with, a lot of big challenges. And so the moon is going to be an ideal place for us to learn how to live in this challenging deep space environment. And once we do that, we will continue. Again, right now, the eyes are kind of sometime in the 2030s time frame. It would be very interesting to see.
So I kind of wanted to go back to something Emily had said in a previous answer when we were talking about searching for life on Mars. You had mentioned that we'd have to look for signs of life, probably under the surface, as a lot of particulate has collected on the surface. So you have to kind of dig to look for it. How deep? This is from Liam in Frederick County 4-H. How deep do you think we'll have to dig if we were to find signs of life?
That's a really good question. We have already evidence of water. That we didn't. I don't know, Brian. Do you know how deep do we have to dig to find the water ice?
Well,
Mars, I think they're on the surface, aren't they?
Yeah. So that's a really good question. We have some areas where people are thinking that they may see signs of liquid water, not deep, a matter of centimeters to meters beneath the surface. But again, we're not sure. And you can interpret that evidence in a lot of different ways. There was a whole big debate about things called recurring slope lineae, these dark streaks that would go down slopes. And people said, oh, that looks like maybe water running just beneath the surface. Maybe, maybe not. So we're really not sure if we do, but because Mars's environment is so dry and the thermal environment is so extreme and the radiation environment is so extreme, we would expect that we would have to do some digging, probably. But there's also a few places that really catch our interest. Skylights or entrances into lava tube caves. And perhaps those caves could be wonderful places, for us to live, but also they'd be great places to search for life. So conceivably, you might not have to dig at all. You might just have to be brave enough to go down into one of those Martian caves.
Okay, so following speaking of features on Mars, I know the Mars Trek video talks a lot about the Grand Canyon of Mars and all of the craters. We had a lot of questions from folks wondering just how many craters there are on Mars.
Millions and millions and millions. And there's more all the time. One of the things this is really exciting is our Mars Reconnaissance Orbiter spacecraft that is orbiting Mars right now. It has actually captured the formation of new craters. It's seen craters that have formed in the period of time since it has arrived in orbit around Mars. That's pretty good. That's pretty cool.
So there are actually scientists out there that study craters, and they want to count how many craters are on Mars. So there is actually a database out there that keep track of the number of the craters that we have found, but we don't believe that we have found them all yet. And they have the craters comes in very different different size and shapes. And therefore, it's hard to be able to, figure out what all those are on the surface of Mars, because we have a lot of images that we brought back from our orbiter's spacecraft, and there's a lot of data that we have to sift through to find them.
Awesome. I kind of wanted to also then go back to like the rover and instrument question. So sending all of these missions to Mars, we had a lot of people chatting in the comments about when you were talking about fail rates. How do we make sure that these instruments, these vehicles are powered? Like, how are they powered? And how do we make sure that we can use them for the length of time? I think it was Curiosity. Didn't Curiosity last much longer than we thought they would? So question, like, how are they powered? And then how do we make sure that we can use them for the length of time that we need to?
Very good questions. Some of the rovers have what we call the solar panel. So it was mounted on the rover, and therefore, its power can be powered by the solar sunlight. And some of them have batteries. I'm not familiar with the battery technology. Brian, are you?
Yeah. So for instance, Spirit and Opportunity were solar powered, as you mentioned, whereas Curiosity is actually nuclear powered. It uses what we call a radioactive thermocouple that generates heat. And that's also how our next rover, Perseverance, will be powered. That's kind of important because, as Emily mentioned, when you have a solar-powered rover, you're deriving your power from sunlight. And as the rovers would drive along, they would kick up dust that would land on those solar panels. And so as Spirit and Opportunity were driving along, as the solar panels got dustier and dustier and dustier, we'd see our power levels dropping lower and lower and lower. And that's why they figured that the lifespan of those two rovers would only be about 90 days. But something really cool happened. As Emily points out in the video, you can see these dark tracks across the surface of Mars. Those are the paths of dust devils. And as the dust devils would go along, they'd kind of vacuum up the dust off the ground, and they'd expose the dark rock beneath. But occasionally, you get a dust devil or a Martian wind that would go over a rover and clean it off. And all of a sudden, we saw the power levels go right back up again. So we would call those cleaning events. And we ended up depending on them because they kept the rovers going for a lot longer than anyone had originally thought. Now, with the new nuclear-powered rovers like Curiosity and Perseverance, you don't have to worry about whether it's winter or summer, whether you have a dust storm. They can keep on going. So these are kind of like the Energizer bunnies of Mars.
Thank you, Brian. I did get, this made me start thinking about what's in the Mars Trek video. And again, like the surface and the features that you talked about. And the question I had that, when I watched the video about like, does Mars have, does they have volcanoes and crevices? Does it have plate tectonics? So I think other folks had similar questions about like what that all means for how the planet works. I know Crescinda and Tiffany had the same question. If there's evidence of volcanoes and lava and all this stuff on Mars, is there seismic activity? And what causes that?
That is a wonderful question. And up until very recently, Emily and I would only be able to just shrug at you when you would ask such a question. But recently, we had a new lander reach the surface of Mars, and that was the Mars InSight mission. And Mars InSight is the first mission designed specifically to study the interior of Mars. And on board it, it's a very, very, very sensitive seismometer. And it's actually listening for Mars quakes. And guess what? It found them. Mars does have quakes. And as a matter of fact, if you look in the video, you'll see we visit an area on Mars called Cerberus Fossae. And this is the first active seismic area that we have identified on Mars. And you look at the Cerberus Fossae, there are these really wonderful, amazing cracks going across the crust of Mars. It's really quite spectacular. And using Mars Trek, you can actually fly down into those cracks. It's a lot of fun. But yes, we know that, well, Mars doesn't have the same kind of plate tectonics that we have here on Earth. Mars's crust is indeed an active place.
So we talked about specifically some of the missions we've made to Mars. Perseverance just launched 2 months ago and will be landing in February. So we've had some questions about, how does NASA start planning missions, like the mission timeline? I'd love for you guys to talk about sort of what goes into planning a mission and how long does that take?
It takes a long time, many, many years. So, we have what we call project life cycles for a mission, which start from formulation. Actually, pre-formulation, there is concept. So we gather, the scientists or principal investigator will start proposing those concepts years before the mission, can be put together and fly. So that is the first thing, is come up with concept, and then they have to formulate the project, and then they have to go through a number of gates, including such as design phase, implementation phase, and test phase. So in order to build a spacecraft, it's a lot of work, a lot of efforts, and it takes a number of years to do that. And then, depending on the destination, Mars is, it takes 6 months to get there. But some of the farther planets, it takes years. For example, the messenger missions that, fly to Mercury, it took 6.5 years to enter the orbit, to orbit around the planet Mercury, to be able to study the geography and also the magnetic field and also the chemical compositions of that planet. So each mission that we're talking about years of efforts to put in there from start to the end?
That's a really good point. You got to be patient when you're proposing missions. But just going on something Emily said there, she mentioned messenger mission going to Mercury, and we have another mission right now that is on its way to Mercury. And as a matter of fact, as we are speaking right now, this is called the Bepi-Colombo mission, and this is being done by our friends at the European Space Agency and Japanese Space Agency. It is passing by Venus right now as we speak tonight. And it is using that pass by Venus to change its speed and its direction on its way to getting to Mercury. So that is something that is really exciting. That's happening as we speak. And while you folks are going to be using Mars Trek extensively, keep in mind solar system treks have a variety of other portals so you can explore other worlds. And as Emily can probably point out real well, there's one that relates very well to this Bepi-Colombo mission.
Yeah, so we talked about the messenger missions that went to study Mercury. So Mercury actually has a really thick atmosphere, to protect it from different space junk or space debris. So the planet is guarded by numerous impact craters, showing that it has been bombarded by many different asteroids and debris, the impacts from them. So one of the really spectacular crater on Mercury is called the Colaris Basin, which is about 950 miles across, and it's ringed by miles-high mountains. It's actually one of the largest in the solar system. So we'll invite you to check it out. There's many fascinating landforms on Mercury. And what you can do is use the Mercury track portal, which we just recently released for you to explore Mercury.
So we have a lot of questions coming in about Mars and like the difference between Mars and Earth. So I think one question a lot of folks have asked is, how long is a day on Mars, and how do we think that might affect, I know with deep space travel, like how does that affect humans?
Very good question. One of the nice things about Mars is that its tilt of its axis and its rate of rotation is very, very similar to that of the Earth. It's a matter of the day on Mars is a matter of only minutes different than the length of the day here on Earth. So that's a good thing compared to when you go to the moon. A lunar day is the equivalent of 28 Earth days. That would be pretty hard to get used to. But a normal cycle of, if you're only off by 15 minutes like you would be on Mars, that's something we can probably get used to pretty well. So that's one of the attractive aspects of Mars, is that the length of the day is really quite similar to what you're used to here on Earth.
Another question. Oh, go ahead, Emily.
Oh, sorry. Yeah. However, I think it's because the distance, from the sun to Mars is a lot further away than the distance from the sun to the Earth. So it makes it the length of the year is longer. So on Earth we have about 365 days a year versus Mars we have over 680 Earth days for a year of Mars year.
Wow, so almost twice as long.
Mm-hmm.
Some other questions that I think are slightly related, but I'm going to make them two-part because they're not quite the same question. But we had a lot of questions about the atmosphere of Mars, and I know we talked a little bit about that, about what it used to be, what it is now. So two-part question is, since we've started studying Mars and sending instruments there, has anything changed? Like, do we see change over that like short of a period of time in a planet's life? And second question, which I thought just was fun, is when you're on the planet of Mars, what color is the sky? Is it different? Because the atmosphere is different?
Cool. Yes, so we'll take that second question first. What color is the sky? It's kind of orangish to pinkish. And part of it depends, a lot of it depends on the fact that you do have this dust suspended in the sky. You have that. Mars is a dusty place. And that's something we're going to have to learn to live with, deal with when we live and work on Mars. Now, out here in California, you may have seen pictures recently. We had really bad forest fires. And all that particulate stuff in the sky, all that smoke, turned our sky here a really weird orange. As a matter of fact, a lot of us were, for a while, joking that we were living on Mars. And so it's a very similar thing. Now, because of the composition of the dust on Mars, and it being so rich in essentially rust, that kind of tinges it to an almost pinkish color. So that's, instead of the nice blue sky, get used to an orange to pink sky on Mars. In terms of changes, well, yeah, we see that the Martian atmosphere is a dynamic place. I mean, it has clouds. It has storms. It has dust storms that can end up covering the entire planet. We have a spacecraft in orbit around Mars right now, Maven, that is actually measuring the amount of atmosphere being stripped away. We also are starting to discover that as the solar wind hits Mars and is directed by localized magnetic fields, we've recently discovered Mars has auroras, kind of like the northern and southern lights. So yeah, it's a neat, dynamic, wonderful, interesting world.
We just have a few more minutes left, so if you have any last questions, folks, get them in on the comments. I've made some notes of a couple to keep us going. So one question, again, pretty foundational, so sorry we didn't cover it earlier, but how many moons does Mars have?
Emily?
There's our two. One is called Phobos, and the other one's called Deimos. And in fact, the Phobos is one of them. NASA is working with JAXA and also the Russian Space Agency to develop a Moon-Mars exploration mission to study primary Phobos and then on to study Deimos later. So Phobos can be a satellite moon that can be a stepping stone for us to, before we go to send human to Mars. Potentially, we can go to the moon first. And in fact, right now on the solar system track portals, we have 9 available track portals, and we don't have Phobos or Deimos there yet, but Phobos track is something that we are currently working on, and hopefully that it will be available for you to explore Phobos sometime later.
Do we know a lot about the moons yet? I know you said we're going there, but like, for example, do the moons have like a moon cycle like they do, like our moon here on Earth does?
Yeah, they're interesting places. First of all, the moons of Mars are very small. So our moon is about 2,000 miles across. Phobos is about 14 miles across, and it's the big one. Deimos is only about 7.5 miles. So they're little places. You'll look at them and you'll see that they are not nice, perfect spheres. They look more like cosmic potatoes. And they're kind of weird shaped. There's a lot we don't know about them. Where did they come from? How did they form? Some people think that they are captured asteroids. Mars is, after all, right next to the asteroid belt. But other people look at them as having been perhaps remnants of debris that was thrown out by a giant impact. If we look at Mars, Emily was talking about the Caloris Basin on Mercury and how big that is. Well, there is possibly, we're not sure yet, but if you look at that big area where we think there may have been once a great northern ocean on Mars, that might actually be a giant impact basin 6,000 miles across. And that might have thrown enough debris out when it formed that what we may have in Phobos and Deimos perhaps is some of the remnants left over from that Titanic impact. So one of the things we're really looking forward to doing is getting samples back. Emily mentioned that Moons of Mars Explorer mission from JAXA, and we would love to get some pieces of Phobos back to study them and figure out, okay, just where did these moons come from?
Awesome. Well, thank you. I apologize to everyone in the comments that we can't just keep going all night long and have you guys answer questions because there's so many good ones in the comments. I will say a lot of the, like, what's the difference between Mars and Earth, temperatures and all that stuff. I'm going to plug the Mars Base Camp kit from 4-H. There's a great section in our youth workbook, which you can actually view on 4h.org/STEM challenge. It's a digital file that you can see, like, straight up what is the difference in temperature, difference in length of day, all of that good comparison information to see how Mars is different. I'm going to leave Brian and Emily with one last question that almost everybody in the comments has had. A lot of very interested STEM and science folks in the comments. How do you work at NASA? How do you get a job or an internship at NASA?
Oh.
Easy question.
Well, yeah, and there's actually an easy answer. There is a website, I believe it is intern.nasa.gov. And we'll double check that, but that's one of the wonderful things that Emily and I experience every year. This year's been kind of an exception, but every summer we get tons and tons of students coming to NASA to do summer studies at NASA and do summer internships. And so there are centers all across the country, and you can go to intern.nasa.gov and you can find opportunities to come do some really exciting work at NASA.
Wonderful. Well, thank you so much for joining us tonight. I know that we started a little bit late, so thank you for sticking around a little bit longer with us to compensate. As any other folks have questions, we'll be here in the comments, but for the most part, I would say check out Mars Base Camp. As I said, some of the questions are answered there, but also the Mars Trek video that Emily and Brian put together has a lot of information about past missions to Mars, all of the cool things we've learned so far. It feels like you're actually walking and flying on the planet. I wish I had Google Cardboard and I could do like a little virtual reality tour. I know that a lot of 4-H clubs are going to be playing around with the solar system Trek system itself for future projects and programs. So basically go and explore. Emily, Brian, what is the URL for the solar system Treks and Mars Trek system?
Very simple. Trek, TREK.nasa.gov.
Great. And much like the Mars Trek, video that you've seen, there are solar system treks for so many other planets and moons and places that you can really explore the solar system. So thank you so much for joining us. It's been awesome. I've got a lot of questions answered myself. And it was great chatting with you tonight, Emily and Brian.
Well, thank you very much, Mandy, for hosting this. We appreciate that. And thank you for all the wonderful questions. It's been fun.
Yeah, and thank you everybody for joining us.
Thank you all so much.
All right. Good night. Bye-bye.